Today, inshallah, Rabbil Alameen, we will talk about the buoyant force, as we agreed together. The buoyant force, last period, forgive me because I'm, alhamdulillah, yani, not so good today, not so well, alhamdulillah, today, yani. So try to concentrate as possible, as it, inshallah, and I'll do my best, inshallah. The buoyant force, which has the symbol FB, as you see, we said that if we try to put a ball, for example, in a swimming pool, okay, you feel something push your hand up. You feel something push your hand up, okay? This push up is called the buoyant force, okay? So the buoyant force, the first point we got from this argument is that the buoyant force appears when an object is placed in what? Is placed in liquid. By the way, not only liquid, but any fluid, because the buoyant force is one of the properties of what? Of the fluid. Well, so this is the first point. It appears when the object is placed in fluid. Okay. Number two, it's upward force or downward force. It's upward force. Excellent. It's upward force. Okay. So, Mr. Is it always upward? Yes, it's always upward force. Okay. Can someone tell me another force that's always downward? Yes, it's the weight. The weight is always downward. So the weight is always the weight of the object, of any object, okay, which is the force of gravity that's acting on the object. The weight is always downward, vertically downward, and the buoyant force is always vertically upward. So they are two opposite forces. Well, now let's go to the definition of the buoyant force. Okay, so the definition of the buoyant force is an upward force, or it's an upward force. This is point number one. So I put number one here. Okay, and let me remind you that you have to write this in your copybook, because inshallah Rabbil Alameen, each period I'll ask you to scan what you wrote and send it to me on the Placera. Okay. Well, this is an upward force that's exerted by a liquid, not only liquid or gas, Mr. But the book wrote a liquid. The book wrote a liquid. Yes, I know. The book wrote a liquid, but the reality is liquid or gas. Okay, the fact says that, not me. On an object that's immersed in or floating on it, it means the liquid or the gas. Well, so this is the definition according to what we described a few minutes ago. Well, so we have two cases. Number one, immersed in. Number two, floating on. So we have two cases of the objects. Okay. Number one is immersed in. Immersed can be described with another description. You have to memorize this statement or this description like your name. Immersed can be described in another expression, which is completely submerged, like this. This is completely submerged that I'm pointing at now, and this is completely submerged. So this is the first case, which is immersed in the definition. Okay, so what about the second case, which is floating? Floating is that case here, okay, floating, and it has another expression, okay, which is partially submerged, and you have to memorize these two expressions. Floating means partially submerged, okay. Here, let's go back to talk about the cases of immersed or completely submerged objects, okay. We have two cases. The first one is the suspended object. What's meant by suspended? Suspended means it's hanging inside the liquid. It didn't reach the bottom of the bottle, okay? So it's hanging, it's suspended, okay? So I think the teachers of chemistry, if you study that, okay, call some kind of solution called it suspension. Why? Because the particles are suspended, okay, in this type of solution. Well, okay. So here, excuse me. لو سمحت يا استاذ اللي فاتح الكاميرا. Okay. So here, the submerged, the completely submerged may be suspended like this, or sinking. Sinking like this. Sinking means it reaches the bottom of the bottle, okay, or the swimming pool, or the any container, okay. Well, there are important points to be known about these two situations of completely submerged objects. Here, when you see anything that's suspended in a liquid, you have to know that the density of this object is equal to the density of the liquid. The density of this object is equal to the density of the liquid, so it's suspended, okay? When you see anything that's sinking in the liquid, that means the density of the object is more than the density of the liquid. Like when you throw a piece of, let's say a nail, for example, in a liquid, it sinks to the bottom. Well, now, inshallah, we'll talk about the floating object. When the object is floating, some students, sorry, some students say, imagine that floating means floating means the object will be flying on the surface. يعني no submerged part. Okay, no submerged part. No, this is not floating. It's not floating. This phenomena that you are talking about is called surface tension. This is completely different phenomena, and it's not included in our portion. Okay, so, and even in fact, we are not interested in such phenomenon. Okay, so when we talk about floating object, in fact, we are talking about a partially submerged. Partially submerged means part of the object. A part of the object is below the surface, inside the liquid, and the other part is above the surface. That's called partially submerged or floating object. So when will this phenomenon take place that happens when the density of the object is less than the liquid? Well, so now, inshallah, we will talk about something that's called the apparent weight. If you are in the swimming pool and you try to carry your brother, for example, okay, you will find carrying your brother is so easy. Okay, so you may say, "Oh no, I feel strong." Okay, what's the reason? The reason may be the cheese of Milkana or Al-Marai or President that I ate today morning. So now I'm stronger. So I can, such that I can carry my brother. In fact, this is not the fact. You're not stronger. If you are on the shore or the side of the swimming pool, okay, out of the swimming pool, and you try to repeat the same thing and carry your brother, you will find him heavier and you may not be able to carry him. Okay, so what's the difference between the two cases? Who can tell me? If you want to answer, raise your hand. What makes your brother easier to be carried when you were in the swimming pool? محمد المؤتمن، تفضل يا محمد.
Sorry, I was muted and I didn't know it. Okay, so it's because the water in the swimming pool exerts a buoyant force that helps lift his weight.
Excellent answer. Thank you very much, Muhammad al-Mu'taman. Thank you. Respect. So, because of the water in the swimming pool exerts upward force, and this upward force is opposite to the force of the weight. Look at the diagram in the figure. We have buoyant force acts upward, which is FB. For example, it's 5 newtons. Okay, and the weight of the object, which is weight, WT means weight, and it has the symbol FGO. FG means the force of gravity, which is the symbol of the weight. And O and O means the object. So FGO means the weight of the object. It's written in blue here, okay? It's 20 newtons. And both are opposite to each other. So if you try to feel this object, you will find its weight appears as if, or seems as if it's what? 20 minus 5 or 15 newtons. So you will feel it's lighter than its real weight. So the new weight, which is the difference between the weight and the buoyant force, is called apparent weight. Apparent means it's not real. Okay, so here we have a new concept, which is the apparent weight. So if I ask you, why do we feel objects lighter than their real weight when they are submerged in fluids? You will answer, you will say what? You will say because of the buoyant force, which is acting upward, opposite to the weight, so it decreases the weight. Okay, well, so now here, inshallah, Rabbil Alameen, we will compare between the real weight and the apparent weight. Let's agree together that we will give them these symbols. Real weight of the object, it's FG O, and we will give them the notation O. O means they are of the object. Because sometimes we will use FG F, small f, instead of O. Sometimes we will write what? Small f. Okay, which means what? Which means fluid, because we will use the weight of the fluid. But till now we didn't use forget it, but I tell you that why do we use the symbol FGO? O means object, the weight of the object. In the apparent weight, we'll give it the symbol FGAPP. And this is always of the object, no apparent weight for anything rather than the object. Well, what is the real weight? It's the force of the real weight, okay, is the force of gravity, and it's always downward, okay? And it's the weight in air. Yani the real weight is the weight in air. In fact, this is not accurate word, like this is the term that we agreed together, especially in our book. What about the apparent weight? It's the weight of the object when it's in a liquid or a fluid generally, okay? A fluid rather than air, because someone may say, Mr. Air is a fluid, okay? So we said a fluid rather than air, okay? Another fluid. Well, what's the measuring unit of the weight? The weight is a force. So any force should be in newtons. Any force should be in newtons. Well, what's the direction of the real weight? It's always downward. What's the direction of the apparent weight? It's also downward, because this is the apparent weight, not the buoyant force, by the way. Well, how can we calculate the apparent weight? I think you remember the apparent weight is the mass times the free fall acceleration. Weight equals mg. This is a song you have to memorize like your name. Weight equal mg. Weight equal mg. Weight equal mg. What's the weight? What's the weight? The weight of the object. What's the m? M is the mass. What's g? G is the acceleration due to gravity or the free fall acceleration. Well, so this is the first formula can be used. The weight of the object is mg, MOG, okay? Mg in SAT exams, in SAT 2, it's almost not 10 meters per second square, except for in any case, he gives you another number like 9.8, okay? So you would use the number he gave in the example or in the question. Well, but let's remember, who can tell me M equals what? Density times volume or density divided by volume? Who wants to answer? M, which is the mass. MO, the mass of the object. طيب ضياء الشوبكي تفضل.
Mass equal density times volume.
Excellent answer. Thank you very much, Ria. The mass equals times density times volume. So I can replace the mass here by rho times volume here. So instead of mg, it became rho v g. Rho is the density, v the volume, okay, times g. We talked about g, okay. And the notation O means means object. I think it's so easy, inshallah. What about the apparent weight? As we said a few minutes ago, the apparent weight is the difference between the real weight and the buoyant force. So the apparent weight is FGO, which is the real weight of the object. You have to memorize this symbol, minus FB, which is the buoyant force. So it's a piece of cake, inshallah. If anyone have anything to ask about, please raise your hand and take the mic and ask. Okay. طيب. So تفضل أسامة. Sorry, تفضل تفضل.
Okay, Mister, I didn't understand the part fluid. The part fluid, which contains a particle, I guess, submit or something like that.
Which here?
No, قبليها.
This one?
Yes.
This one?
Yes.
Or starting here?
No. This one.
This? Okay.
Yes.
طيب أسامة. Okay, Muhammad Al-Mutaman, I will listen to you, but after answering Usama's question. Okay. The floating here, Usama, we have two cases, immersed, and we explained the immersed. Immersed means it's completely submerged. Okay, but floating, what's meant by floating? Floating doesn't mean the object is completely above the surface of water. Yani, for example, if I tell you, is the ship floating or not? Osama, answer. You are unmuted.
It's not.
Yeah, I'm talking about the ship. Okay, the ship. When it's is it floating or not? The ship.
Oh, yes, floating.
Yes, it's floating. طبعا لو مش floating كانت تبقى غرقت. Okay, so
yes,
it's floating. Does it mean all the body of the ship above the surface of water? يعني the surface of water just touches the base of the ship, or part of the ship is submerged in the water?
I guess part of the ship is submerged.
بالظبط كده. So we say it's partially from the word part, okay, not completely, partially submerged. Part of it is submerged in the object, in the fluid. Okay, so when we say floating object, means part of the object is submerged and the other part is out of the surface. Is it clear now?
Okay, thank you, Mr.
You're welcome. محمد المؤتمن. Okay, تفضل. Sorry, I'll unmute you. تفضل.
Mr. Can you please go back to the formula to find apparent weight, because I was trying to write it and then you skipped it.
Which one?
Yeah, please.
Okay. You want to re-explain it?
Yeah, please.
Okay. Well, let's go back here to remember that. Here. Okay. We said when the object, and you yourself answered the question, in the object, when the object is in fluid like this, it undergoes two forces. One is downward, which is its real weight, and the other is upward, which is floating force, okay, or buoyant force, sorry, okay. And so we have two equal, sorry, not equal, we have two opposite forces, okay. So if we want to find the resultant, not the resultant, if I ask you, its real weight was 20, but the buoyant force is 5 in opposite direction. So it seems to be
they are different forces, and then it's 20 minus 5 and it's 15 newtons.
Excellent. So it seems to be 15. This is the apparent weight. Okay, it's smaller than the real weight. Why? Because of the effect of the buoyant force, which is opposite to the real weight. So here we said the apparent weight, FGAPP, equals FGO, which is the real weight, minus the buoyant force. Okay? Is it clear now, inshallah?
Yeah. Thank you.
Welcome. So, now, inshallah, Rabbil Alameen, we will talk about, Mr. How can we determine, the buoyant force experimentally? Can we do that? Yes, we can, inshallah. How? Let's see. Imagine that we have this. This is called can. This is called displacement can. Okay, so this is called displacement can. Well, so wait. Okay, this is called displacement can. Displacement can. Why? Because this liquid is still the edge of this pipe. So if we drop this object slightly in the liquid, what will happen? The level of the liquid will move up, will increase. So the increase will be poured through this path to out of the displaced can. Okay, well, so this is the idea of what this is called. What? Called displacement can. Displacement can. Well, to determine the buoyant force, we will hang or suspend the object in a spring balance. You know the spring balance? The spring balance, the balance that we use to get the weight of bags and so on. Okay, so when you suspend the object here, this is the reading, and before putting in the liquid, the balance, the spring balance, will give you the reading of the real weight, because till now the object is in air. Okay, and the balance, which is the real weight, as we agreed together, is m times g, or rho v g. Well, now we will put the object in the liquid. What will happen? It will displace a part of the liquid. So some amount of liquid will be displaced, and this is called displaced liquid or fluid. We will collect this fluid in an external beaker, okay? And in the same time, we will read the new reading of the spring balance, which will be less, because the object here seems to be what? To be lighter, okay? Because it's in the liquid, okay? So we will take the reading, the new reading, which will represent the apparent weight. There is N here, okay? There is N here, okay? The apparent weight, okay, which will be less than the real weight. Well, so we have the apparent weight and we have the real weight, but let's remember the following: apparent weight and real weight, so we can get what? We can get the buoyant force by substituting in this formula. But we found a very strange discovery. What is it, mister? When we find the weight of the water, of the displaced liquid, the weight of the displaced liquid is found to be equal to the buoyant force that we calculated. So from this argument, we can say that Archimedes was brilliant when he got this idea centuries before the Christ. Okay, what did Archimedes do, mister? Archimedes introduced us his principle, which is Archimedes' principle. He said that the magnet magnitude of the buoyant force equals the weight of displaced fluid. This is simply. It means if you want to find the buoyant force of an object, put it in a displacement can, as the one that we showed here, okay, and collect the displaced liquid after this object is balanced. Collect the displaced liquid and put it on a balance and find its weight. This weight equals to the buoyant force. So memorize this statement like your name. Buoyant force equals weight of displaced fluid. Buoyant force equal weight of displaced fluid. Buoyant force equals the weight of displaced fluid by the object when you put the object. Okay, so let's read the complete statement of Archimedes. He said that the magnitude of buoyant force on object in fluid equals weight of displaced fluid by the object. And we can represent this statement in a mathematical formula by this short but important formula. Buoyant force FB equals FGF. Here FGF. What's FGF? It's the weight of what? Of displaced fluid. So F of displaced fluid. O, notation O of object, of the object. I hope it's clear, inshallah. Okay, this statement of Archimedes should be memorized like your name. Okay, well, so the formula of buoyant force from the previous argument is the weight of the displaced fluid. The weight of the displaced fluid, like any weight, it's the mass of the fluid times the free fall acceleration. But the mass of the fluid is the raw density of the fluid times V. Mass is rho times V. Okay, so the buoyant force is rho Vg. Mister, you told us rho Vg is the weight of the object, the real weight. No, the real weight is rho O object, VO object times G. But here FB is the rho of fluid, the density of the fluid, of the liquid, okay, of the gas times the volume displaced, the volume that displaced when we put the object in the fluid, and G is the free fall acceleration, or the acceleration due to gravity, or the gravitational field strength. Okay, so the buoyant force also is measured in Newton because it's a force. Finally, this period. So what are the factors affecting to the buoyant force according to this formula? We know that we almost, not all, but almost the formula. We have density, we have volume of displaced liquid, and we have the free fall acceleration. Okay, so the factors are the density of the liquid, the displaced volume, okay, and the gravity acceleration. But the displaced volume displaced by what? By the submerged part of the object. Okay, so the displaced volume is the volume of submerged part of the object, and we will explain this point several times later, inshallah, again. Okay, all these factors, as any one of them increases, the buoyant force increase. So if we have two fluids, one is more dense than the other, its buoyant force will be larger if the other factors are the same. Okay, and so on. Any question? If you have any question, raise your hand. Muhammad, Mutaman Shefak, you're raising your hand from last time. I don't know if you have a question. Okay. If you have any question, raise your hand. طيب, I hope it's clear. Inshallah Rabbil Alameen. I'll send you some questions, some this video on the Classera, and next period, inshallah, we will solve mathematical skills or working examples, because the time now is not enough. Okay, so we will solve mathematical examples on these points, inshallah, to make more practice of them before taking a homework one day. Thank you, everyone. I hope, inshallah, you understood. And assalamu alaikum wa rahmatullahi wa barakatuh.